Hello everyone and welcome to this episode of Bug Bounty Basics. Today we're going to be talking about a really interesting bug called information disclosure. And information disclosure type vulnerabilities are so varied. There are ones that are more technical and ones that aren't. They're a great first bug simply because you find them in so many different places. They apply to almost any application. There's ones that require more technical skills and ones that don't. And actually you can find it through just using a website. So if you maybe don't have access to a laptop, or maybe you have access to Chromebook rather than a full operating system, this might be a great bug to start out with because you don't need to use burp necessarily. You can find it through regular testing, and it is one of my favorite bugs for that reason, especially to recommend for beginners. However, I will say this relies a lot on luck for quite a lot of these findings. You're hoping nobody else has found it before you. It's not as guaranteed as other bugs are, that, eventually if you keep on working, you'll find something. You can really lose out to other bug hunters. So with that in mind, we've first got to thank our series sponsor. This entire Bug Bounty series is sponsored by BUGCROWD. BUGCROWD have agreed to make this whole series possible. It would not be possible without their support. And all you can do is just sign up and start hacking on one of their programs. BUGCROWD is the best place to start hacking, with a wide range of public and private programs from APIs to desktop applications and everything in between. Not yet ready to jump into a public program? Fill out your platform CV and sign up for a waitlisted program. Tell BUGCROWD a bit about your skills, previous certifications or experience, and they'll match you up with the right program using their industry-leading crowd match technology. Whatever your level, there is a place for you in the crowd. Okay, so types of information disclosure. Now, I've broadly put in 4 different types of information disclosure based on likely first bugs-esque. And I've ranked them here from ones that require, less technical skills and one that requires quite a lot of technical skills. So we have personal identifiable information, so that's information about a person that shouldn't be public. We've got access control issues that allow read access, so being able to access somebody else's account details. We've got error messages / software disclosure type vulnerabilities. These are often part of like a bug chain because you can cause an error, see what software they're using, and then use that to try, say, for example, known vulnerabilities or application level DOSes. And at the very end, we have looking through code to find comments or API keys or just anything sensitive that might be in there. So let's start by talking a bit about personal data. And we're going to be talking about this through the lens of GDPR. GDPR is quite a wide-ranging legal framework for what personal data is and data protection. And I think it's a really great way to frame any kind of PII-based impact because GDPR actually applies to any company, no matter where they're located in the world, as long as they are processing data of EU citizens. So GDPR was a data protection law that was passed in the European Parliament. So it applies to EU countries plus the UK because the UK ratified it before we left the EU. So it's what's called an EU regulation, which means it has to go into the national law of each country. And in fact, it has wording in there that says that if a country has less GDPR access or less data protection legislation than GDPR, that actually you can't store data in those locations. It has to meet at least that EU data protection boundary. So there are also things called directives, so those aren't the law, but this is a regulation. And it overhauled a lot of countries' laws on data, so I'm going to be talking primarily about the UK implementation of it. It's fairly standard for the EU versus like the UK, but it's the one that I know the best because obviously I live here. Still, I think it's really great to know this, even if you don't live in an EU country, even if you live in India. So the fines for GDPR are huge and they can be applied globally as long as a target processes data from an EU country. They can be subject to huge fines if they don't meet that requirement. So if you're talking to, a target you're working on, and let's say they're saying, oh, I'm not sure if this is designed to be public, you can say, well, actually under GDPR it really shouldn't be, and if you accept this risk and anything happens, you will get a fine, even if you're not an EU-based country. So it's a really, really good way to frame your impact. So GDPR defines something called personal data, which is a very broad definition, and it's basically any information that identifies somebody. For example, their name, but it doesn't have to be their name. It could be a unique identifier. It could be an IP address. It can also be a collection of data. If you say there is a cybersecurity YouTuber based in the UK whose name starts with an I, you can see how that would kind of narrow down the scope. You could have lots of these individual pieces and still be able to identify somebody. If you can't identify somebody, it may not be personal data. Really common one of this is companies. So company data is not the same as personal data because you can't use it to identify a person. And another common one is anonymized data. So where your data, say, isn't being stored with unique identifiers, with a name, with something that identifies somebody. And this is including if the data is wrong or out of date. If it relates to an individual, it is personal data and it is subjected to GDPR regulations. So some common misunderstandings of data protection legislation. So it includes any information that identifies somebody. That is what's considered personal data. It can be an email address. It can be a name. It can be something else. Personal data doesn't have to include somebody's name. It can include lots of individual points of data that point to a person. Any information being public isn't necessarily bad. There is this understanding of risk. So a lot of people will think about things like email disclosure. Email disclosure is a fairly low risk type of information disclosure that may be considered personal data, yes, but it's not subjective to the same regulations as something like special category data. So not all data is equal. Some pieces of data are considered more sensitive. Financial, health, ethnicity, sexuality. Essentially, if you can be discriminated against for it, it's going to be special category data. That does have requirements of security. So not all personal data has to be secure, but these ones do. And finally, that a business based in the US doesn't have to follow GDPR. That's not true. If they serve EU customers or UK-based customers, they do have to provide the same storage. And actually, if you are in the EU, you probably know this already, that a lot of companies will actually give you an error that says unavailable for legal reasons on some websites because they don't want you to access their website if you're in the EU. So before I continue, if you haven't seen last week's video, I would really recommend you go and watch it because I talk in there about the basics of how to test for access control, but I'm going to talk more in detail about sensitive contexts. So watch that video first, then watch this video. So some things to consider when you're hacking a target is that you could have sensitive content but that aren't necessarily personal data. So I'll use an example. If you're doing some kind of education app, maybe it's used for exams at universities, maybe it's used to generate points for something. The quiz answers would still be sensitive because that could allow someone to cheat. That's not personal data, that's not financial data, whatever. It is literally just because of the context in which the target works. So same idea for advertising. So being able to understand how things are being recommended is huge for people who work in advertising and marketing because they really want their stuff to be recommended to people. We saw this with Twitter. Twitter actually released a CVE because of the ability to mess with their recommendation algorithm. If you've got subscription services, any kind of bypass of a paywall could be considered sensitive. It depends on the client there because some things are just accepted as a risk. People will try and do things like this. But you think about something where you can have a trial of a product and you can extend that trial. that could be sensitive. Again, it's not always sensitive. It really does depend on the client you're working with, but this is the thing you can think about when you're thinking, okay, what kind of sensitive information disclosure can I find? You have social media app, you have private posts or anonymous messages where you don't want to be associated with a username. You can also have, again, private, that should be considered private. So my recommendation, if you are looking at finding these bugs, is think about how is your target making money. So if they're making money through subscriptions, see if you can figure out, how to bypass a subscription. If they make money through advertising, see if you can bypass the recommendation algorithm and therefore able to get more eyeballs on your ads without necessarily the paying for that. Think about what would ruin the app, what makes the app fun. If you've got a game, you might consider, sensitive information / business logic areas to be cheating. So think about the kind of customer that your target has. What would make them annoyed? What would be really frustrating for them? If you've got a university and you're running exams, obviously if a student can cheat, then that would be really serious for them. How could you game the system in place? How could you, say, get your video to the top of YouTube? How could you make more money out of something that really doesn't have, you showing me how to make a little bit of money? And then finally, think about what your target values. Things like anonymization, compliance. Something like a bank is going to have a very different threat model to a social media application, and that's really important. So those are the more non-technical types of information disclosure, right? So let's have a look at the technical. So let's look at those error message and API keys instead. So these bugs, these information disclosure bugs, either disclose some information about what a target is using or what a third-party target is using. Figuring out a error message, figuring out the software running, figuring out the operating system is not a security bug alone, right? That doesn't demonstrate impact. And in bug bounty, we need to see impact. So things like API keys, even if they are committed to a GitHub repository, can be rotated every month. And that key is then only good for a month. After then, it's not worth it to an attacker. Things like exact software, so if you can see, it uses Java, well, you can choose a log4j attack. You see how the actual you're using Java isn't what we think about. It's that next step. It's, okay, this is Java and, right? This is this software version and this is attacking, whatever. It's running a system that can run arbitrary commands and here is my, command execution, right? There are ones that are more recon focused, so finding hidden directories in error messages, being able to see the code. Again, these are very technical bugs, and if you've got a background as a programmer, these can be really great choices for your first bug, simply because you kind of have an advantage there. So some of the best ways to do this is by using fuzzing payloads. These are my two favorite fuzzing payload GitHub projects. So the first one is payload all the things. That's sorted by vulnerabilities, and you can just go into there, go SQL injection, and then they have the, generic, you can use this to figure out what software version you've got. And then FuzzDB, again, it's got this category for attack patterns, and you can just throw that into whatever fuzz you're already using. Maybe that's Burp Intruder, maybe that's FFUF, maybe that's something else, Deerbuster or whatever. Two really, really, really good GitHub repositories. I really do recommend you look into these. If you're looking into one of them, make it payload all the things. So helpful when you're just starting out because you can get so much information from it. Now, the next tool I'm going to recommend is something called TruffleHog. So TruffleHog is a command line tool that can search through GitHub and GitLab, and I think it's just those two. I think there might be some more on the way. And it will find API keys for specific APIs. So, for example, AWS. Really, really common for people to commit their AWS key. and it will show you the raw result, but it will also test it for you. So you can very quickly go through, if you've got a code at GitHub repository, run TruffleHog on it, wait, and then see what comes up. Now, obviously, this is a very good tool. You're likely going to get results for kind of a limited amount of time, right? Because once one person has reported this, and it is easy to do, you're going to get duplicates. The problem with anything where you're using a lot of automated tooling, and that also includes fuzzing as well, you are taking a risk that you will get a duplicate, right? That is a risk you've just got to accept that you're taking. It's something that, I saw it a lot when I used to work for BUGCROWD, is that people would run a nuclear scan, submit it, and get annoyed because the customer already knew about it. Well, you're not the only person who has access to these tools. So again, if you are using automated tools, you're going to get more duplicates simply because everyone else is using them, including, by the way, the target you're working on. So what happens if you find information about a piece of software? What can you do with it? Well, first off, you can craft a specific attack. Java deserialization, log4j. You can also look at what people have recently been disclosed and see if there's, a specific vulnerability that affects it. Now, you could generate new API keys, so you might be able to take an AWS key and then turn that into more API keys. You might be able to see files with personal data in them if they're using some kind of flat file database, which, to be fair, is very, very rare. If they've got their data stored in files and you're able to read the file because it's got a debugger on it, and it's just outputting to the web browser, you could potentially find something there. You could have a look at the comments to understand how the code works. Code review skills is actually something a lot of bug hunters don't have, and learning that can really give you the upper hand, especially if you're already somebody who knows how to program. You might be able to see old admin panels that are not in use because you've got a generic, let's say they're using cpanel, in which case you can go to cpanel.domain name and then look at that. You might be able to sell data to a competitor if they have some kind of arbitrary file read. You might be able to use that in order to access data. And the final one is access a third party. With cloud security, this by far is one of the most common vulnerabilities, right? Being able to access AWS, huge, right? That can cost a company thousands of dollars in literally minutes. Importantly, what I want you to know is that you cannot report a security bug until it has a security impact. No security impact, no security bug, don't submit it, because they're just not interested. Either you're going to have to tell people why this information being out there public is bad, or you're going to have to demonstrate that by actually attacking it. So that is everything that I have to say about sensitive data. This is a really broad bug category, and a lot of it can be found by actually just using the system as intended and then having these unintended security outcomes. If you are interested in these, I really recommend you go through like Medium or the Bug Bounty subreddit or Twitter and read disclosed reports, because they are very heavily context dependent, right? The bugs that I found do not apply to every single client. They are very particular because they're within that sensitive business context. But anyway, I hope you all enjoyed that. Next week, we're going to be talking about burp add-ons and some of the fun burp add-ons. And I'll show you how I use some of them in part of my workflow, and hopefully that can help inspire you. So thank you very much, everyone. I will see you in the next video. Bye, everyone.